Does that mean we're letting folks in at this point?
Yeah, we'll give it just a minute. It looks like people are still joining. Good evening, folks. We're going to give it just another minute while we wait for a few more attendees to get on. All right, we'll go ahead and get started. Good evening, and thank you for taking time to join us here at Marin Water tonight. I'm Adrienne Mertens. I'm the Communications and Public Affairs Manager for the district. And this is our second of our planned series of community workshops for the Strategic Water Supply Assessment. And tonight you're going to hear from Marin Water staff, as well as some of our consultant team from Jacobs Engineering, who will be providing an update on the progress made on the assessment process so far to date. And once this informational presentation concludes, we are then going to move into question and answers from our attendees, and attendees will have the opportunity to ask questions directly of our panelists or provide any comments on the information covered this evening. And so when we get to that point after the presentation, I'll signal for a Q&A section. And at that time, if you would like to ask a question or offer your thoughts, you may indicate so by using the raise your hand function. If you're watching on a computer or smart device, then that's at the bottom of your Zoom screen. And if you dialed in by phone, you can press *9 to let us know your hand is raised. And our board secretary and tonight's Zoom host, Terry, will move one by one through the list of attendees with raised hands. And once you've had your asked your question or shared your input, she'll lower your hand for you. And then I do want to note that we will post the slides from this evening's presentation, as well as the recording of this workshop, on our website by early tomorrow. And then just one final note, there are a number of acronyms that are used frequently in the water industry, and we've tried our hardest to avoid the use of those throughout the slide deck tonight. But for the few instances where they may pop up during some of the data charts that you'll see in the slides later, as well as in discussion, we've provided a glossary of terms, which Paul will get to here early in his slides, but I'm also going to post in the chat as a link so that you can reference those if they're helpful throughout the presentation. And I'll turn it over to Paul now, our District Water Resources Director, to kick off the presentation. Thank you.
Great, thanks, Adrienne. So welcome, as Adrienne said, to our second public or community workshop on the Strategic Water Supply Assessment. I think it just pause for a moment and remind us sort of why we're here, and I'll go back a little bit in history, so I won't be too long, but, after the drought of 1976 and 77, the district engaged in studies, and those studies resulted in water supply projects, right? At the time, I think in 1979, Sulahuli Reservoir was constructed, which added 10,000 acre-feet of storage. The district also developed plans and contracts with Sonoma and built an aqueduct to bring supplemental water from Sonoma County Water Agency, doubling the size of Kent Reservoir from 16,000 acre-feet to about 32,000 acre-feet, and built out a small recycled water program, which is still operating today and with a capacity of about 2 million gallons of water per day. And so, just as we did then, we are today through this strategic water supply assessment, responding to, again, a historic drought that we've just experienced in 2020 and 2021. And that drought was followed by an equally historic downpour of rainfall in October of last year and December of last year. Prior to that, we had been engaged in an emergency intertie project looking for a water supply to provide drought relief. As we were, if the drought had continued, we would have been in a very poor situation for water supply. So the deluge provides us the time needed to really consider our next actions in terms of developing a resilient water supply portfolio for the district. Tonight's presentation will provide you with an update, progress to date on where we are in terms of the project, and a look ahead at our schedule and next steps. Our team tonight will be presenting information in a sort of summary format for a number of the presentations that we've already had to date. And those subjects will cover everything from demand and demand management to hydrology and looking at droughts and what we should be planning for in terms of drought. And then we'll also take a look at the model and baseline scenarios that we can develop and understand how our system may respond in those conditions. And so Lucy Croy is our water quality manager, and she'll be taking us through the demand section. Armin Munever with Jacobs Engineering and Marcelo Reginato will be taking us through most of the rest of the presentation this evening. Before we get into that, as Adrian had mentioned, we do have sort of a glossary of terms that once this is posted on the website, you can kind of use. I won't go through all of these here, but there are a number of acronyms that are used in places throughout the presentation. And we'll try to call those out as we go through. So at this point, I'd like to hand it over to Armin with Jacobs, who will take us through the project and process overview to get going.
Great, thanks, Paul, and glad to be here this evening. We can advance to the next one, please. Okay, so just an overview of the project. Really, the strategic water supply assessment, as we're calling this work, is really meant to build on the past planning efforts that the district has performed and look at kind of how we can fill in the gaps in some of the water supply alternatives. I really look at this this assessment as an opportunity to look really broadly at the water supply, water management alternatives, and to develop a roadmap for the district moving forward. We're looking at a comparative analysis of water management or water supply options available to the district and provide recommendations. We are trying to cast a really wide net of what those water management alternatives could be. And then kind of underlying all of the kind of impetus for the project is this accelerated pace of climate change and greater hydrologic extremes. So Paul just mentioned the most recent hydrologic extremes of our extreme drought, followed by an extreme wet period. And I think that kind of seesaw of back and forth between wet and dry periods is one of the major signals of climate change that we're having to deal with throughout the Western United States. So the assessment is really meant to address kind of 4 high-level questions. The first is, what is the current risk to the district's water delivery reliability under current and projected future droughts? Then how much water supply may be needed under different hydrologic drought and demand scenarios? And then what is the range of water supply or water management alternatives that could increase the resiliency of the district system? And then the pros and cons associated with each of those alternatives. And then finally, we want to take all of that information and provide recommendations that can be built into the district's planning for near-term investments, but looking out towards long-term drought resiliency. And one of the key goals, the initial efforts of the project was to look at goals and develop draft goals. So we've worked with the team to develop at least 4 high-level goals related to water supply, making sure that the district is providing reliable and resilient water supply now and the future, ensuring that the water quality that is delivered is of high quality and protects public health. We're looking at sustainability and environmental goals to protect and enhance the biodiversity of the watersheds from which most of your supply is derived from, and protect that for future generations. And then finally, looking at how do you maintain and improve district's infrastructure and operations in a cost-effective manner. So we want to be cognizant of all those goals as we're moving through this effort. So one of the main areas is looking at kind of how we want to start off and kind of set the stage for what is drought and how do we want to manage through it. So we'll have a little discussion here about the types of droughts and what's the cause of droughts. I think underlying the assessment is really trying to grapple with uncertainty. We understand droughts and the seesawing of hydrology has a lot of uncertainty associated with it. And then how do we best respond to that uncertainty to make decisions when we kind of have an uncertain future? So we've developed a scenario planning approach that helps us grapple with that uncertainty. And then finally, we're really looking at consideration of both supplemental supply and demand management as 2 of the main knobs that could be turned to help address any future reliability challenges. So just to go over the scope of work of the project, there's kind of, maybe we can let all the animation go. Thanks. So we've kind of broken the overall scope of work into the first element. So how do we understand the current risk and establishing goals? So we've kicked off initial efforts in developing goals and strategy. We're in the process of developing and refining a decision support model to help us evaluate the effect of hydrology on the system. And then we're developing a robust set of water supply and demand scenarios to explore that future. Those 3 are kind of what we're calling the understanding risk and establishing goals component. The next block of 2, next, if you can go back 1, thanks. Yeah, the next block is really about, okay, what can we do about those risks that as we observe them? So if you did nothing, you have these risks, but that's obviously not what's going to happen. The district wants to be proactive and manage that risk in the future. So what types of water management alternatives could be considered? And then how do we identify the pros and cons of those alternatives? And then finally, all of that will be prepared into a final roadmap with recommendations. So that's the overall process. We are largely in the first block with starting to develop the water supply alternatives, which will be discussed in future meetings. Okay, so one of the key elements of the work we're helping the district with right now is really looking at water supply and demand scenarios and really recognizing that the future is uncertain. There's uncertain climate aspects, there's uncertain variability in droughts, even in the historical records. There's uncertainty in demands and in policy and regulations. So we want to take all these elements of uncertainty and craft them into representative scenarios that allow the district and the public to see how the system might perform under those various scenarios, and then look for robust solutions that work across all of those scenarios. So our scenarios will include historic droughts, climate projections of future droughts, some paleoclimate reconstructions, and paleoclimate essentially being reconstructions of climate based usually on tree ring reconstructions, and then a couple stress test hydrologies that we're developing that we have not observed in the past, but have a plausibility of occurring and want to stress test the system around that. So the scenarios we'll look at, first off, the scenarios are intended to capture the uncertainty. They're not predictions of the future, but they're plausible futures. And they're really to explore the areas that are not within the management control of these decisions. So we don't control what climate gives us. We don't necessarily control what statewide policy provides. So we're looking at those areas of uncertainty. With wildfires, we don't control all the elements of wildfires. We can mitigate the impact of them, but we don't control the primary drivers of them. So we're looking at different water supply variables with respect to future scenarios. So historical climate and these paleoclimate reconstructions. We're looking at different water demand projections as well. So recent trends, different changes in population growth and land use, and then whether they're passive levels or increasing water use efficiency over time. And so maybe just to set the stage on the drought scenarios, a little bit of historical reference. These two maps that are being shown on the screen are work that's done out of Center for Western Water Extremes out of Scripps Institution of Oceanography. And really a lot of this focus is atmospheric rivers tend to be the drivers of most of the moisture that's provided in the bay and the North Coast in particular. And those high flood events are driven by really extreme atmospheric rivers, which bring these large atmospheric moisture flows to the West Coast. And many of our droughts are driven by the absence of these atmospheric rivers. And so this really nice work out of Scripps tried to dissect the last 3 years of climate conditions and the absence of atmospheric rivers. So for example, the panel on the left shows the landfalling locations of atmospheric rivers. And that's for both water year 2020 and water year 2021. So what's really most striking in the map on the left is the lack of landfalling atmospheric rivers. So we had extreme dry conditions largely because those atmospheric rivers did not occur. So on average, California experiences 7 kind of stronger atmospheric rivers in a water year. In the water year 2020 and 2021, 2 water years combined, only 3 of those events occurred. Then 2022 arrived, and we had really an exceptional atmospheric river that Paul mentioned earlier, which brought kind of a saving grace to the water supply conditions of the North Coast, but it still was only 1 or smaller events. So we're still in an absence of kind of back to normal atmospheric river events. So we can look at some of the indicators of those events as well and look at our droughts. So this graph here is showing every dot represents one particular year from 1886 to 2021. And the black lines that go vertical and horizontal kind of represent the average conditions. So anything that is above the horizontal black line would represent a year that is warmer than normal. And anything that's below that horizontal black line would represent a year that is cooler than normal. And then the vertical line would represent anything that is to the right of that vertical line is something that was wetter than normal, and to the left would be drier than normal. And I think the key message from this, first off, there's a lot of scatter and variability in the system, and this is how our climate works in the Western US, where we have high variability year after year. We have 1983 all the way to the far right, an extreme wet event, which was not particularly warm or cool, but was an extreme wet event. And then if you go to the upper quadrant to the left, these are really the events that we care about from a drought management or water supply management standpoint. And I think the key thing to identify first off is 1976 and 1977, which are kind of all the way to the left, but in the middle part of the graph. that represented our most extreme 2-year drought prior to this current drought, and one still represents the most extreme. But those were not particularly warm droughts. If you look at our 2014 and 2015, which are the red dots to the top, those were very warm years. And 2020 and 2021, and potentially 2022, we don't know where that one will end up, all fall in this area of extreme warm and dry conditions. And the importance of that is that we end up with droughts that are both dry as droughts are defined, but also warm, and they have their impacts in terms of soil moisture depletion and potential wildfire contributions. If we go to the next slide, this is the same type of plot, except we've pulled out one representative climate projection. So now this is looking out to the future. And I think the key point here is first off to note that virtually all of these years in the future through the projections are going to be warmer than our historical conditions. That's the attribution of global warming, and we'll have warmer conditions throughout. But we'll also have droughts that are really to the far extreme here. So those representative years of 2020 and 2021 that we observed are not anomalous from the future projections. They're actually probably much more likely to be representative of what our future droughts might look like. So we can see, if we just point the orange ones to the top, we've got, the years are not really as important as the sequence, but there's a 3-year sequence of kind of extreme drought with the three orange dots there, and extreme warm conditions. So this is kind of what the new normal might look like for future droughts. Also, just to look at the flip side is we'll also be flipping between dry and wet. So taking advantage of those sequences of really wet years and how we can transfer that into dry year reliability is important. Next slide. So another way to look at the drought is about how much deficit has occurred from normal. And this is, I'll take a little bit of time to explain this graph. What we did is looked at historic observed stream flows from 1940 to 2021, and we used as a reference condition the Russian River near Guerneville, and we're in the process of updating this for total local flow, but it'll be quite representative. And then what we've done is looked at what are those severe and some of the longer term droughts look like from that historical record. And every year that had something that was below normal represented the start. The first year was a 1-year drought, and then if it continued to be below normal, it was a 2-year drought, and if it continued to be normal for a 3rd year, it was a 3-year drought, and so on. And we've plotted a few of those to illustrate the type of drought that we might be experiencing. The first one to point out maybe is the one that's listed as 1977. So that's a 1976 and 1977, the green line. And that still represents the most severe 2-year drought in the historical record. But you can see right next to that is 20 and 21, or 2020 and 2021, which is almost as severe as 1976, 77. And water year 2022 is not yet plotted because we don't know that final outcome. But you can also see from that historical record that we had some really quite long, prolonged droughts, like the one shown with 1992. That's a 1987 and 1992, which was really a 6-year drought and had a substantial amount of deficit in stream flow. So we want to look both at these short, severe droughts as well as some of these prolonged droughts that we see in the observed record. And then if we go to the next slide, so this is the identical slide. The gray, we just grayed out all the lines that were on the previous slide. And then we've plotted 2 of the more extreme future projected droughts. And those are the ones shown in blue and green here from two individual climate projections. What you can see first off is that that 1987 and 92 is not the longest drought we might see on record. We have some that are pushing the 6, 7, 8 year projections. And we do not yet see droughts that are quite as severe as our most recent, but we fully believe that those are possible. It may be a limitation in the climate projections. So both observations and the climate projections are suggesting that we're going to have severe, we can go to the next slide if you don't mind. Yeah, so just kind of summarizing what I just had walked through. The climate projections are indicating potential for warmer and more severe droughts. So droughts that might look quite a bit more like 2020, 21, 2022. And so when we look at how we want to plan for droughts looking forward, we want to look at both these short and severe type droughts like we've just observed and experienced, 2-year droughts. We also want to look at short and severe, but maybe not quite as short, so 4-year extended severe droughts, which are certainly plausible. But we also want to characterize the nature of these longer term droughts, which could be 6 to 8 years of prolonged droughts like 1987 to 92, or the future climate projections, which look like they may be even more severe than that historical record with respect to the prolonged droughts. Okay, well, I think, and I'll come back and help summarize, but I'm going to hand it off to Lucy, who's going to talk about water demand. So,
thank you, Armin. Lucy Croy, the water quality manager with the district. And so building off the drought scenarios that Armin just went through, another key input into this evaluation is water use and water demands. So stepping back and looking back historically, and then we're going to dive in a little bit more into current and projected water use. This chart is really interesting, showing water used over the last 100 years or so. The black lines showing water use, so water production, and then the green line showing population just below it. And so there's a couple trends that are interesting here. You can see that up through about the early 1970s or so, there was a pretty significant increase in water use that aligned pretty closely with population growth. And then at that point, we see it kind of steady off, and then a different trend occurs. And that really is driven by more of these cycles of drought and events such as the recession, which is shown in yellow. And so through these periods, what we've seen is kind of this cycle of a higher demand just before a drought, dropping into a drought where demand really drops pretty significantly. Shown, in 1977, it drops close to 11,000 acre feet, and then a rebound. So a rebound back up, but maybe not fully back up to the peak at which it was before. So it's kind of this interesting cycle that we've seen as we've progressed through. And then at the tail end of this, you'll see the drop that we've seen really through this last drought in 2021, so 2020 to 2021. We're still dropping right now and watching our production, but we expect that maybe coming out of this drought, we could see a little bit of a rebound, but overall the trend since early 2000 has been an overall drop in water use, even though population has continued to slowly grow. So looking at this a little bit differently and pulling in monthly data, this is showing now the last 5 years of water use by month. And really what's interesting about this is the seasonality that we see in demand. So in our winter months, December through February or so, we see demand is pretty stable through those months, nearly around 1,500 acre feet or so. But as we get into the peak kind of summer months, July, August, it nearly doubles. So it nearly doubles to about 3,000 acre feet. And so what we really account that for is irrigation, outdoor irrigation. And that's what the large increase during those summer months is coming from. And notable also on this chart is the purple line shown kind of at the end of each of these bar charts. So that's from last year, 2021, when we had put into place drought restrictions for outdoor irrigation and then limited down to 1 day of irrigation per week. And you'll see that it's pretty significantly lower through those months, aligning with the idea that a lot of this has to do with outdoor irrigation through those peak months. So tying in the average use year over year, and given the cycles that we see going in and out of drought over the last 10, 15, 20 years, going into this assessment, we are approaching these cycles by using a 5-year average. So using the 5-year average of just under 25,000 acre feet, which comes from our urban water management plan. And this chart and table actually breaks down that use by sector. So starting to dive into how is the water used throughout our system, by different sectors. So single family and multifamily are shown on the first 2 lines, accounting for about 67% of our overall use. And the rest is going, so the remaining 33% is shown below that. Going to commercial, institutional, and other is water losses throughout the system. The landscape is also included there, and that's large irrigation meters that are typically going to either commercial or sometimes also to residential facilities as well. But really what's notable here is the significant portion of our water use that's going to the residential sector. And that's why as we move through more of this presentation, you'll see that we dive into the opportunities that there are for potential savings due to this high usage that we see in the residential sector. So one of the opportunities that we've had recently to dive into more use in the single family and especially the residential sector is it's a number of Flume devices that have been installed throughout our system, nearly 1,700 devices at this point. And each of them is shown by a black dot. And so you'll see it's pretty spread out through the system, giving a pretty good spread throughout different communities. And these devices are all installed by customers onto their own meters. And it's been really powerful because the water flow is recorded every 5 seconds and then analyzed. And it allows water use to be analyzed both indoor and outdoor. And it's disaggregated so that we can start to understand how the water is being used and by what different use. So whether it's a clothes washer or a toilet, Flume is able to start to disaggregate that data and divide it up that way. So diving first into residential indoor use, shown here is the gallons per capita per day. So first, real jargony word, but really this is just gallons per person per day. So what we see is through a number of these Flume devices were installed actually starting through the drought, so starting in July 2021. So the data we have is starting in that period. And what we see is that indoor use has stayed pretty consistently stable across that period. So peaking around 34 gallons per person per day, but really significantly a very low and a very efficient use within the indoor residential. We could see a small bounce back coming out of the drought, but we expect that most of this isn't necessarily behavioral. We think that most of it is probably due to low use toilets or the devices that are actually installed within homes. And I'll get into that a little bit more. So stepping back a little bit, some of the interesting data that we have due to all these devices that are installed throughout the system, we see that by volume, toilets and showers are by far the majority of use within indoors. So toilets and showers account for just about 70% within the house. And so if we're looking for potential savings, that would probably be it. Previously, clothes washers were an opportunity for savings, but now it looks like most have turned to high efficiency clothes washers, and we see that it's only down to now 6.3%. The green area over there on the right, the miscellaneous indoor, the vague green it's actually faucets. And so it's a little bit harder to nail down, but just wanted to note that as well. So diving into toilets, one of those major components of use within the indoor residential use. Interestingly enough, we see that they're very efficiently used. So they're very efficient right now. This chart is showing that up through about 70% of the toilets that are used and flushed, it's about 1.9 gallons per flush, which is a very efficient standard. On a median level, the median is coming back at 1.6. So that means that gallons per flush, we're seeing about 50% are less than 1.6. And that means that 50% of the Flume devices installed and toilet flushes within the service area are below that threshold, which is really quite incredible and quite efficient, probably more than we were expecting, given that this is one sample size for us at this point. Okay. So another, now jumping to outdoor, we're shifting, looking at another chart that is showing outdoor gallons per household per day. And the reason for this is that it makes a little bit more sense to look at outdoor use by household rather than by person. And so what we see here is that kind of the peak is during those summer months of around 144, and this is during the drought, of course. Which is still relatively efficient. And then moving into winter, we always think that maybe irrigation just disappears and turns off and is turned off going into winter, but it looks like overall the average was around 27 to 21, even during the drought months that we had last year, and then when we still had quite a bit of rain. So it's interesting to see that there's still some irrigation occurring at the household level during those winter months. And then another chart showing some interesting data about outdoor household use. When each of these devices are installed, the customer has the ability to self-enter what type of irrigation system they have. So whether it's a sprinkler system or a drip system. And so this is somewhat self-entered, but overall, what we see is that given this data, interestingly most, is that the sprinkler systems are the highest usage. And then just below that is drip. Another data point that's not shown up here, though, is that nearly 60% of the flumes that responded in this data set were drip. So we do have, at least from the respondents of this data set, most were drip within Marin. So already moving towards a more efficient outdoor water use approach. But looking down towards the bottom, there's an orange and a blue line. You see that is garden hose and none, and those are both significantly lower, kind of coming together during the October months, which is actually when the huge storms hit. So you see that large drop coming in there. So this chart pulls together some of the different data that we just presented. The orange line is showing indoor use. So as you can see, it's relatively stable throughout July through March, staying around 30 gallons per person per day, as I mentioned before. And then on the green line, that is outdoor use. So outdoor gallons per person per day. So during the summer months, we see outdoor gallons per person per day a little bit higher. And then during the winter months, we see indoor use actually higher than outdoor use. And the yellow line above that is the combined use. So adding those two lines together, what the overall residential gallons per person per day is. So all of this data on its own may be interesting, but you may wonder, what does this mean and how do we compare to others? So we pulled in a few other agencies that some may look familiar from the Bay Area, and then some are also, all of these are considered very highly efficient agencies. And you'll see that we're shown to be, based on this data set, extremely efficient. Over here, at times, Inverness is the only agency shown in these quarters in which there's a lower indoor gallons per person per day. But within the other agencies, even East Bay Mud or Contra Costa, which we would compare ourselves more likely to be similar to, given that there are other Bay Area agencies, we've actually been lower in indoor gallons per person per day. And then looking at outdoor, there's similar trends. You see that during Q3, which is kind of the end of those hot months, our outdoor use was significantly lower than the other two Bay Area agencies that we pulled in for this data set to look at, given the restrictions that were in place. And so just showing overall that there's opportunities within outdoor irrigation for us to continue to refine and continue to find savings. So pulling all this data together, what does it mean for this project and for this strategic water supply assessment? So we'll be using the 5-year average that pulls together kind of a balance between the drought cycles, so just under 25,000 acre feet as current demand, and use that as our baseline. And then really looking at this data on a very small scale, the opportunities that we see for water use savings are residential outdoor use, and the opportunities that we will be pushing out and pursuing is turf replacement, finding the technology and the efficiencies that for irrigation controllers to really manage how water is used outdoors as well. And tying into that landscape, so irrigation on a commercial level, changing out plant material to be more water efficient, and just using overall irrigation efficiencies that improve how water is used throughout our system. And then another approach is really just minimizing the losses that we see throughout our system and finding ways to minimize those losses and manage our system. So demand management, in summary, really offers a potential modest water use reduction over the planning period, and that will be incorporated into this project moving forward in the evaluation. So given that, I'm now going to be passing off the baseline scenarios. Is it Armin?
Yes, yeah,
Okay.
thanks, Lucy. And Paul, I think we can go maybe straight to the next one, but talking about how do we use the supply conditions that we've identified through some of the historical and future climate projections with the water demand assumptions that Lucy has just walked through. We really want to combine those water supply and water demand into reflective scenarios that are capturing that future uncertainty. And in the next slide, I think we can. So we have a draft set of scenarios right now that are listed here, five distinct scenarios. And each of these scenarios are really meant to explore uncertainties that we don't control as part of this effort. So the first scenario is current trends, kind of looking at a continuation of recent observations. We have an accelerated conservation, which looks at a little bit higher levels of conservation. We've combined scenarios 3 and 4 are really looking at different types of droughts, hydrologic, hydroclimatic uncertainty, so the short and severe drought. And then scenario 4 is looking at this prolonged drought that might be beyond drought of record. And then finally, scenario 5 is still draft in progress that we're trying to work through, but we're likely to look at an abrupt disruption in the water supply and what that might mean for water resiliency. And so then this table here gives a high level view of the assumptions that we're currently proposing to go into each of the scenarios. So each scenario represents a row. And so in scenario 1, which we're calling current trends, we would look at the historical observed record of hydroclimate variability. We have over 100 years of record that we're utilizing. We would look at passive level water conservation savings. And we'd have operational assumptions of the way the district water system is operated, which would reflect current operations, kind of a local water supply preference with supplemental water purchased from Sonoma Water, with Castagna Pump Station rehabilitated as it is as of today. Scenario 2 is very similar to scenario 1, except we would look at further conservation savings, so both the passive plus programmatic conservation savings. Scenario 3, where we'd be looking really at stressing the system with a 4-year drought, that severe 4-year drought. So looking at hydrologic conditions in 2020, 21, and then coupling that with a 1976 and 1977. So looking at a really short or a severe 4-year drought. Scenario 4 would look at, okay, what is a longer range, prolonged, extended 6 or 7-year drought based on the climate projections? What does that do to the system? And then finally, the last one, which I mentioned we're still working through, is looking at, okay, that's severe drought, but also combining that with a potential high wildfire likelihood within the watershed. And that would manifest itself as potential for operational disruption. So kind of a post wildfire runoff with high sediment loads and potential reduced ability to take water and treat that water during that period of time. So again, each of those scenarios are not meant to be predictions, but they're plausible futures that we can explore the reliability and the resiliency of the system around. Okay, and one of the key elements that we'll be looking at as we go through each of those scenarios is what is the minimum acceptable marine storage levels at which we would say now the system is being severely challenged. And we've worked with the team to identify what those levels could be. And so we built this up as dead pool, or essentially inactive zone in the reservoirs where water cannot be physically removed, or there's some uncertainty in the ability to take that water and treat it. That was roughly 10,000 acre feet. Emergency storage, so looking at some supply to be held onto in the reservoirs should an abrupt disruption occur, roughly 15 to 20,000 acre feet. And so if you combine those two levels of the total almost 80,000 acre feet of total storage that the district operates, somewhere between 25 and 30,000 acre feet, it will be a zone of where we are using that as an indication of really challenging conditions for which a management action may be needed. And so that's what we've built up. And then one of the key elements that we're working through is, okay, how do we assess whether we've hit those thresholds and other metrics? And we're going to switch here and talk about the decision support model, which is going to help us characterize that through a quantitative analysis. And I'll hand off to Marcelo at this point.
Thank you, Armin. So I'll be talking a little bit about the decision supports to our model here. It's a mathematical model. And I'm going to summarize things here. First, why, right? Why we're building this tool. Then what is the tool? So I'll describe a little bit, talk a little bit about what is the tool that we're using. And then finally, how we'll be using our decision supports model. So the very first thing, why, right? And you saw today, Armin went through all the different hydrology conditions that we might see in the future. There's a lot of uncertainty there. And then Lucy went through the demands, right? And then Armin talked to you about all the scenarios that we're planning to run. So how you make sense of all that information? That's why we need a model. So the model is just a mathematical tool that we input all that information, all that data, and we run to see how the system performs under these different scenarios and different conditions. So that's the main purpose of the model, is to provide information for us on how the system performs. Going back to the first questions that Armin had in the first slides, this tool will tell us how reliable the system is under all these different uncertain conditions, right? So the climates, the droughts, and the demands. The model will tell us how much water we need to keep a reliable system under all these different scenarios. And we're going to test all these different water management alternatives. We're going to have a workshop that will talk about management alternatives, what kind of projects we might need in the future. So this tool is a water balance and system operations tool. It's a representation of the marine system, but as a water balance with some operation rules. With a lot of operation rules. What is not, it's not a hydraulic model. Some of you might be familiar with hydraulic models, which has the entire representation of the system, every pipe, and you can get pressure, can get velocity on those pipes. That's not what this model tool is. So if you go to the next slides, this is what is the model, right? What we're including this in this model. And I presented a slide in our first workshop with the entire extension of the model domain, which starts all the way in the Russian River. But here I'm focusing in the model schematic just for your system. So you can see it starts with the Sonoma water, the Petaluma aqueduct, and then the water comes into your system. Which is the gray oval right in the middle. That's the representation of your system, where the demands are. And you see on the left all the 7 reservoirs that you have in the system. The watershed divides, so it means that you need to pump water from those reservoirs across the hill into the distribution system. And then we have many alternatives that we want to build in this model. So we'll be turning on and off those alternative projects and evaluate what will be the response of the system when we do that. So in a big summary here, what are the model inputs and outputs, right? So the model inputs, the main model inputs, the river flows, and that's mainly on the Russian River. So it's a part of the system that I'm not showing on this picture here. So it's the river flows. Reservoir inflows, so we have data for your 7 reservoirs, how much water is going to the reservoirs. Local supplies, if an agency has local supplies, what are those? Or if we're planning to have local supplies. The system demands, any flow limitations that are important and we have in the system, for example, the Castania pump station. And how we operate the system, right? How we move water from these reservoirs into your distribution system. So those are the main inputs. The main model outputs are results for all the scenarios. So all the scenarios that Armin described earlier. So that will be results for those the scenarios. And that includes the system deliveries for the different supplies. So how much you are getting from your local reservoirs versus how much imported water you're getting. So you're gonna get outputs on the system deliveries. The reservoir levels, so we're gonna see how the reservoir levels are under these different scenarios, and system flows across this schematic that I'm presenting. So those are the main model inputs and outputs. This is what the model is. And finally, how we're gonna use the model here. And how we're gonna use the model, I'm gonna first talk a little bit about validation, and then I'm gonna show you how we're reading the model results. So the validation is important because it's how we gain trust on the model calculations, right? We wanna, how sure are we that this model is a good model, it's a good representation of your system. So we currently build all the equations in this mathematical model, all the rules, we have the demands and flows, and we test the model. So our validation, we use historical demands. So in the past, what are the demands that you had in the system? And the historical inflows to the reservoirs. So we get those two inputs, we put in our model, our equations will run, and then we'll compare what the model is doing versus what actually happened in reality. In the validation period we're using here is from 2009 and 2021. We had a good amount of data for this period. What we'll be looking at? Mainly, we're going to be looking at reservoir storage, the delivery of the supplies, and the operation of the water treatment plant, the two water treatment plants. As an example here, I have this chart that is showing how the model is performing against this historical values for storage. So this is the total surface storage for marine. And the blue line is the measure, historically, the reservoir levels. And the black line is showing the model results. So our validation approach is that we look at this, we review the data, we see how off we are on our operation on the comparison of these lines on the charts. And then we'll go back to the model when we add more detail as we need. We refine the model as we need. So that's called the top-down model approach. So that was the big picture about the model validation. And I'm also working with the marine staff. They have a huge knowledge about the system to also validate what we're seeing as a model results. So, and finally here, how are we going to look at the model results, right? Once we run. So in the previous slides, I was showing to you just the validation periods. It's up to 2021. But now we want to see what's going to happen in the future. We were trying to see what could happen in the future. Nobody knows what kind of flows we're going to have next year. So our approach here, we start with some initial storage conditions. And let's say in this example here, we're starting at around 75,000 acre feet of storage. And what we do, we look at all the flows that we have historically. And we can recreate flows going all the way back to 1910. So we get flows from 1910 to 1920, and we plug in our model with the operation of the system, with the system facilities, and with the demands that you have right now, right? We plug those past hydrological sequences, those historical flows, and see what would happen in our reservoirs if we had the past hydrological conditions. We run this multiple times. Because we have flows going all the way back to 1910. Right now we have 107 years, and we run all these years through our model. That's why you see all these different lines here. So this is just a sample of model results for storage for one scenario. So we pick one scenario and we run all these different hydrological sequences through one scenario and see what would happen. So you see one line that I'm pointing there, the flows from 1976 to 1980. So that was, like Armin pointed out earlier, that was a really dry period, the 1976. And you see, really, it would bring our reservoirs all the way to 10,000 acre feet of storage. So that was the 1976 to 1980 flows. So then we move. We get to 1975 to 1979 and so on and so forth. So, and how you make sense of all these lines, right? If you have to ask yourself, what are the chances that the reservoirs will be down to 10,000 acre feet next year, right? So basically how many lines reach to that level? That's the second plot on the bottom. So the color indicates the probability, the chances, the frequency of these lines to reach a certain storage level. So if you have a question, okay, how low, what is the probability of your reservoirs to drop to the zone that Armin described, the emergency zone between 25 and 30,000 acre feet next year? So it seems that could be between 1% and 5%. That's the lighter shade of red and the little darker shade of red. And you can see on the plot above, there are like just one line, that was just one trace of hydrology that was crossing that zone, but there are like a few more that were crossing the probability between 1% and 5%. So that's how we're going to compare different scenarios, how we're going to look at the results from a probability, from a statistics, and how we'll make a decision regarding our alternatives. So with that, I'll go back to, yes, Paul, for a summary.
Yeah, Armin, are you doing this section or you want me to do it?
I think so, yeah.
Yeah.
If you can go to the next slide.
Yeah.
Yeah, so just to wrap up, I know we did kind of a deep dive there on the model, but felt it was important to depict how the model will be used in this analysis. So just to bring us back where we are in the project, where the model is that second element that we're talking about, the scenarios or what will be input into the model, and then the water supply alternatives are what will come back for a broader discussion on what are the alternatives to resolve any areas in which there needs to be an improvement in the resiliency or the reliability of the system. And the next slide just talks about the types of water management options that we're considering. So we're doing a deep dive in water reuse, both direct potable reuse, indirect potable reuse, use of water for environmental releases, an expansion of local storage, either raising or dredging, interties, either from the East Bay or North Bay Aqueduct, the demand management that Lucy had gone through before, looking at water conservation and how effective is that in helping us resolve the resiliency, desalination, looking at Sonoma water options. Are there ways to augment or improve the efficiency of taking supplemental water from Sonoma water? And then other types of water management alternatives, which may be looking at fog harvesting or evaporation control, cloud seeding, watershed management. We'll do a deeper dive at the next, another briefing for that, but that was the kind of the big picture of alternatives that are being considered. And then the evaluation process, which will be conducted, we'll look at how each of those alternatives, first off, how do they perform in achieving some of those objectives that we outlined in the beginning for the resiliency goals. What was their water supply reliability capability? Are they improving water quality? What's the cost of implementing them? And then we'll have additional evaluation criteria that will help discern between the alternatives. So how do you know whether when one is better than another or different than another? We'll use the evaluation criteria. And the draft set of criteria that we have is on the right, on the table to the right. So we'll be looking at cost, certainly cost, both capital and annual operating costs, the timing, how long would it take to implement a particular alternative? What's the environmental impacts of that alternative? How feasible is it from a technical standpoint? What are the energy implications? So what the energy footprint associated with an alternative? Permitting legal challenges, any social impacts, both positive or negative socioeconomic impacts, and then jurisdiction. So who needs to be involved in implementing that? Or is it many entities, or is it all within the district's control? And then finally, we'll look at how do each of those individual alternatives perform, what combination of alternatives could and should be considered, because we don't think there's a silver bullet of a single alternative. It's likely to be a combination. And then what's the portfolio strategy that gives the most strategic implementation for achieving reliability over the long term. So where we are in the process right now, we're still doing full quantification of scenarios, and we're hoping that gets advanced in the next couple of weeks. We are updating the decision support model that Marcelo talked about earlier, and we've got a whole team working on development of water supply alternative, including alignment, cost, feasibility, and then we'll be applying the evaluation criteria to that. So there's lots of work underway. I think the purpose of today was to share where we're at in the process with the community and take any questions. So Paul, did you want to talk about the upcoming workshops and close this out?
Thanks, Armin. Just on the right here, we've got just a note that we've got some board meetings coming up in June, most notably the next one, June 14th, which will be dedicated to this project, and in particular, more details, the full quantification of scenarios there. And later in June on the 28th, we'll be getting a look at those water supply, or what we're calling water management alternatives. And then there's, in sometime late July and August, there's a couple more meetings to discuss those steps mentioned there. And there'll be at least one more public workshop, perhaps in August sometime, date to be determined. And Adrian's going to walk us through this last slide here.
Yeah, I had just a couple notes about ways to stay connected with what's happening in the district, and especially with our work on this strategic water supply assessment. First, just a reminder that we do have a dedicated webpage for this project, and that is listed there. The first URL, it's marinwater.org/water supply resiliency. As I mentioned earlier, the materials from this meeting are posted there, and then the recording of tonight's workshop will also be posted there by early tomorrow. And then we have the meeting recordings and materials from all previous board of directors working sessions on the assessment, as well as our previous community workshop posted there as well. You can also sign up for updates from the district through our monthly e-news blast, and you can sign up for that at marinwater.org/e-news. And we're putting monthly updates in there regarding the assessment, when the next workshops are, any board of directors meetings that are scheduled to discuss this topic. And then as well as other critical district updates and water saving tips. And then finally, the district's board of directors meetings are another great way to stay engaged in what's happening with the district. And our board meetings are every other Tuesday beginning at 7 p.m. Unless otherwise noted. And Paul did mention we've got a few upcoming special meetings that'll be focused on the water supply assessment. We've already had some. And you can receive notifications to view the upcoming agendas for each of those meetings and including the special meetings once they're published by subscribing to marinwater.org/get-notifications. And that's all. And I think now we're ready to open it up for Q&A. So at this time, if you would like to ask a question or make a comment, please use the raise your hand feature in Zoom, or if you're listening from a phone, dial *9 to let Terry know that your hand is raised, and we'll go through one by one to get to each of you.
Okay, hello everyone. I only see 2 hands raised. 3, thank you. I feel like I'm in an auction now. Who wants to keep going? The first one I see is Baron Hamill, then Ed Jamison. Go ahead, Ms. Hamill.
Good evening, and thank you for taking my comment. It seems that some of the information about usage that you're using is based on data received from Flume Devices on people's water lines. Per the Flume device stat on my house, it indicates that in this household of 2 people, we flushed 490 times in the month of May. That equates to 15.8 times per day, when in reality it was only 5 to 6 times per day for both people combined. The shower stat says that 408 gallons were used for showers. Now that there's a hot water recirculating system on my water line, I know that we use an average of only 4 gallons per shower. The Flume statistic says that we've taken 102 showers in the month of May, when the reality is between only 25 and 30 showers taken by the 2 of us combined. This implies that the information you're receiving is erroneous and makes me think that information about other areas of water usage might also be erroneous. I thought it would be helpful to bring this to your attention, since accurate information is valuable as you start making decisions about how to proceed with water management scenarios. Thank you again.
Thank you, Ms. Hamill.
Terry, I just for a minute, just if I could, Ms. Hamill, thanks for your comments. If I could, maybe we could get in touch after the meeting tomorrow or Monday and work with Carrie to understand if there's something going on with either your Flume or something that we need to investigate further.
Thank you very much. I appreciate that.
Thanks, Paul. Next, Director Monty Schmidt. Director Schmidt?
Yeah, thank you. I think Ed was going to be up next, so Ed, sorry if we got out of sorts here, but just a couple of quick questions. Back on the slide 18 that showed the future projections on water supply shortages, I thought that was a really compelling graphic, and maybe I should start off by saying, that this has been really informative, for me as a board member, and I hope it has been for all all of our members of our district and our customers and residents to learn about the issues that we're trying to deal with. And hopefully we haven't gotten too jargony. So hopefully, we've tried to keep it straightforward, but this is some pretty complex stuff. But back on, I think it was the projection. I think maybe it's up two more slides. Maybe it's 16. Yeah. So that cumulative deficit, I wanted to ask about that because it's 3,000, almost 3,000. 3,000 acre feet. So that would be 3 million acre feet. And I wondered whether that scale applies statewide, because that would obviously be probably more water than we have in our service area.
Yeah, thank you for that question, Director Schmidt. And I know that we talked about converting this into percentages here. Each one of these will be quite distinct. So if we were to do this for the Yuba watershed or the American River watershed or a different watershed, it will be quite different. I think the important part about this is looking at the relative change amongst the years. So this was done for the Russian River total stream flow. So the Russian River discharges a very large amount of flow out to the ocean, and that's why when there's deficits, they're below normal, they tend to be quite severe.
Yeah,
So they're
that
really
was
meant to be representative of the dry conditions, which would be reflective of what we might see in Marin as well.
Yeah, gotcha. Thank you for that clarification that this isn't for Marin. So I want to make sure that people understood that this was for the Russian River. And yeah, as a percentage, I think that would really help understand the relative order of magnitude of those deficits. The other question I want to talk about, and maybe this is getting to a question that Beryl was asking, is on that Flume data. And I think it's on slide 23. If you can bring that up, that map. You know, one of the things that I did notice when I looked at this is that I mean, this is great data. Data is of course only, you know, as good as what we can collect, and it's fantastic that we're able to have all this information, which it is, you know, I doubt that it's 100% accurate, but I'd like to believe it based on conversations in this presentation that it is very usable data. That can guide how we proceed in our analyses. But one thing I do want to note is, and I'm wondering if it can be spoken to, is the relative small number of Flume units that are actually in the canal neighborhood in San Rafael, which is a pretty high density neighborhood of a lot of homes that you know, that are townhouses or apartments, where there might be you know, obviously very little outdoor water use, very different water use, I guess I should say, than what we might see elsewhere in Marin. And I'm just wondering to what extent that maybe a lack of data in that area where there are so many residents, how that might be influencing our data. And you know, similarly, I think, you know, I wonder, you know, specifically maybe to our outdoor irrigation assessment, some of those numbers, I wonder whether those numbers only reflect people who have outdoor irrigation, or whether that's averaged across all of our customers.
Director Schmidt, I just wanted to see if I understand the question. Is the question, does the number of Flume devices on multifamily units somehow skew the data set? Is that?
Yeah, I mean, when we're wondering, you know, how our indoor water use is tracking, are we capturing? I'm just wondering whether the data captures all the indoor water use patterns and behaviors of a really high density part of Marin. I mean, there are other places that have high densities, but I'm wondering whether the Flume has gone out to more of our, you know, single family residences versus more of the multifamily units, and whether how that maybe if you could explain how that data is parsed out in what we've been seeing here tonight.
Yeah, I think you're right that the majority of the Flume devices are installed on single family residences as opposed to sort of apartment buildings or multifamily units. And so what that really points us to, and as you may recall, we didn't include all of the slides on demand that you may recall. We had slides breaking down, and we did tonight just briefly the one slide, the sector analysis, where single family, even though the combination we talked about of single and multifamily did represent 67% of the water use, the dominant feature of that was single family. So in terms of opportunities for water savings, as we look to outdoor water use, typically, you know, multifamily units don't have very high water use.
That's great. Thank you. I don't want to keep taking up time asking questions. Why don't we, if Ed's Jameson's up next, maybe we can hear his questions or others. And if we have more time, I can come back with a last question just about outdoor irrigation.
Thank you, Director Schmidt. Mr. Ed Jamison, please.
Hi, can you hear me?
Yes, sir.
Thank you. First off, I'd like to say another thank you for another great presentation. You guys do a great job, and the public, I'm sure, appreciates it. I only have one comment. I'd like to suggest that scenario number 5 about abrupt interruptions should include earthquakes. An earthquake could put a pipeline to the East Bay at risk, and at-risk parts of our treatment plants could be taken out of operation, like the existing clarifier that is not earthquake-proof and would take an estimated $25 million to correct. I believe the earthquake risk needs to be highlighted to the board in its consideration of supply alternatives and to encourage the board to support capital projects that will improve our disaster resiliency. Thank you.
Thank you, Mr. Jameson. Okay, next speaker, Mr. Chance Cutrano, please.
Yes, good afternoon, everybody. Chance Cutrano, Vice Mayor, Town of Fairfax, speaking in my own personal capacity as a customer and resident. Yeah, again, another super informative, fantastic presentation and workshop tonight. I really appreciate all this information. I hope I had shared the link to this and had also given this a shout out at the town council meeting last night. I hope that the slide deck could be shared on the respective webpage for this workshop. I think the only thing that was there was a flyer for it last I checked this afternoon. But I think the slides are super informative, and I was curious with regard to like the Flume data. I know this might have come up with electeds before with Marin Water, but since there is so much Flume data and there's so many folks with it that you're pulling information from, it would be really helpful through the process to have a sort of stratified sample across the service area to better understand. I know you probably can't get all of the customers, but yeah, that's sort of a hope out there is coming out of this, like understanding water usage or having some sort of prospective water usage by individual municipality, if possible, or by zip code or something. I think would be really helpful for us understanding, or even just the number of people, customers in a particular zip code could be helpful. I think it's really interesting about the toilet and the shower information. Sounded like there was a customer that had questions about, their data, the accuracy of that, but generally I suspect that, you'd notice outliers as you're aggregating all this data. So not really concerned about that, but feeling pretty interested in figuring out how we at the local level can better incentivize both the Flume to make sure more and more people have it, so we have more and more data, but also some of these, the demand side issues, understanding how we can further incentivize and more quickly transition folks to some of that extremely efficient infrastructure in their homes. So really excited by this and looking forward to continuing the conversation with y'all. Thank you.
Thank you.
If I could just note, we do have the slides published on the website now, and I'll go ahead and drop the link to those in the chat so everyone can access them.
Thank you. Mr. Larry Minikis, please.
Yes, thank you and good evening, and another good presentation. Really appreciate all the documentation, and it helps, I think, a lot of us to see climate change in graphic form and where it's headed. We talk about it all the time, but to actually see some science behind it, some statistics behind it, is rather eye-opening. I also wanted to address scenario 5, which I'm very happy to see there, and that you're addressing post-wildfire sediment loads, which under climate change, we really do have to prepare for disaster, and this is our Achilles heel right now. What happens if? That is really the extent of my comments tonight. And again, thank you for an excellent presentation.
Thank you, Mr. Minikis. Next speaker, Susan Hawk, please.
Hi, yes, thank you for this great presentation. I really appreciated the slide that compared how MMWD customers are doing compared to some of the others in the Bay Area, and of course in our own Greater Marin. But given that this whole situation of droughts and climate change is certainly a national issue and frankly, a worldwide issue, as we well know. I think it'd be really interesting to also compare what other countries are doing, for instance, or, best practices. Like I know Australia has done some pretty amazing things. And for myself, a two-person household and a dog, we keep track of our, gallons per day. And I know we can do a lot better than 34 gallons a day per person. So just an idea that we keep in mind the other best practices that are unfolding and see what else we can learn. And, to compare to, to what others are doing so we can aspire to be even better in terms of our use of water and appreciation of water. So thank you.
Thank you. And we have Mr. Rick Adler. Go ahead, Mr. Adler.
Hello, thank you. I just like to say that the net conclusion I get is that it's just going to get drier and warmer going on. The climate that I found when I first moved to Marin about 60 years ago is long gone. It's heading north. It's probably reaching the Oregon border now. And coming up behind us, LA climate, it's rapidly approaching us. Probably it's in San Jose now. And so eventually we're going to just be warmer and drier with more people. So we're going to have to use every method possible for conservation and additional water supply going on. And the conservation problem is that unlike most of the people calling in today and the board, most of the people in Marin don't pay much attention to the water. It's just, all they know is they turn on the faucet and cool, pure water comes out. It's the way it's always been. And they don't have any expectation that it'll be any different. They don't follow this stuff. And so we're gonna have to be really creative to educate those people. And we're gonna have to use every alternative method to supply. And I urge you to explore new methods rather than just relying on the old methods, like with fog capture and a different way of desalinization that doesn't require the high pressure, expensive method that's currently in use. And so I really appreciate the slides. And I was wondering if you could show the alternative supply slide again so I could do a screen capture of it so I can study it later.
Yeah, of course.
We could also send that directly to him.
But do you have his email?
Yeah.
Mr. Adler, would be okay if we emailed you the slide?
Okay.
Yeah, great.
Terry, do we have his email?
Yeah, I've never really been able to find these slides on your website. So I've been screen capturing them to study them later.
Got it. Well, I can share it briefly
Yeah,
for you.
just go ahead and pull it up.
Let's see, where was that one?
Got it.
Good. Great.
I thank you very much.
You're welcome.
Thanks, Mr. Adler. I have no further public comments.
All right.
Oh, someone just raised their hand. Okay, hold on. Phone number 2310, ending in 2310. Go ahead, please.
Hi, my name is Diana. I am a residential customer in San Rafael. Can you hear me?
Yes.
Yes.
Okay, thank you. I'm calling because I'd like to find out what is being done or could be done in terms of incentives and to help the residential customers and homeowners. And specifically, you know, I hear about a lot of people that are getting gray water systems installed. And, you know, looking at your bar chart where obviously the water usage goes up quite a bit in the summer due to irrigation, as you said. I wanted to know if the district has ever considered doing some sort of mass program where you help your customers get gray water systems installed on their homes, so that all the, you know, the water that's getting used for, you know, washing machine, dishwasher, showers, et cetera, can get, you know, repurposed and reused for outdoor irrigation. That's what I'd like to see as a consumer and as one of your customers. If there's some way that you can do some sort of program where you perhaps, you know, contract with gray water installers, you know, bulk purchases, you know, guarantee them. I think there's a lot of homeowners that would absolutely get this work done on their homes, but can't afford it on their own. So I'd like to, you know, I'd like to recommend and suggest that you guys consider something where you perhaps, you know, do some sort of a bulk purchasing of gray water systems and installations, and maybe, you know, share the cost with your customers and bill your customers out, you know, over a period of a year or something. And I'd like to know if that's ever been considered.
Thanks for your question, Diana. We do, of course, have a gray water program here, and it's in partnership, I think, Adrian, with the Urban Farmer.
Yeah, the Urban Farmer Store, and I'm actually dropping a link to the program information in the chat for everyone right now.
Yeah, so there is some information on our website there, and we have done a number of educational classes over the last, I would say, at least maybe 24 months, and quite a number of people going through the program and learning about gray water systems and some of the benefits and some of the challenges associated with them. But it has been a relatively low uptake for that
but
program.
I think the thing to consider is it's a relatively low uptake because of the cost. And I'd like to see if you guys could, you know, you provide rebates for, you know, low flow toilets and all that. You've done that over the years. You know, could some of your budget go towards sharing costs with the residents to get these systems put on their homes?
Yeah, currently there is a $125 rebate with that partnership program that we offer with the Urban Farmers.
Yeah, but they're like $2,000, you know, it's $2,000 systems from what I can tell. It's about $2,000, and that's, you know, that's too much for most people to take on their own. But I think you'd find huge numbers of people would take it up if it was maybe, you know, $1,000, and, you know, the district covered the rest, and then you bill them for that $1,000 over a period of a year or something. I'd just like to suggest some creative ways of, you know, I think you could get tons of people to buy into that, but they need financial help for it.
It's an interesting prospect, and thank you for that. You know, our water.
Because I would certainly do it if I could get some financial help for it. And in terms of the vendors that would be installing them, because from what I understand, you guys are not involved in that, right? These are private businesses that put in the gray water systems.
Right.
Is that correct?
Yes.
So, you know, advertising, people putting, you know, signs on their lawn, et cetera. And also if you're guaranteeing a vendor, hey, we're going to give you 1,000 residential customers, then they give you a break on price. They're able to buy their supplies in bulk, you know, economies of scale. You know, it seems to me it could be worth, it could be done. And I'd like to really strongly consider that you guys do that, because that would allow individuals throughout Marin to start contributing to helping with this problem. But we need some financial help to do it.
It's an interesting proposal, and we'll take a look at it.
Thank you.
Thank you. There are no further public comments.
Great. With that, I want to thank everyone for attending tonight's meeting, and we will see you next time. Have a good evening, everyone.
Thank you all.